We have already cleared question 1 to 70 and today we are tackling the next 5, question 18 through 22. These questions require a bit more thinking and more steps in the working, but we are going to break them down so they are easy to follow. Let's get started with the question 18. Describe fully the single transformation that maps triangle T onto triangle U. So they are asking transformations. We have 4 different types of transformations: translation, reflection, rotation and enlargement. We need to find which one is this. Further, observe the given triangles. We have a T triangle and U triangle. By observing these two triangles, we can clearly say that this is not rotation, this is not reflection. It is only the shape has changed in size, position and orientation, isn't it? So clearly it says that it is an enlargement. So if it is an enlargement, we need to find scale factor and center. How can you find the scale factor? To find the scale factor, just observe the distance. So observe this long distance and here also observe this long distance. 1, 2, 3, 4. So the triangle T, the distance is 4 units. For the U, 1, 2. So the distance is 2 units. So here the given question is triangle T onto U. In this case, the formula is smaller triangle divided by larger triangle. So actually the small triangle is nothing but image of T, isn't it? So the formula is the length of image divided by the length of object. Here the image is U. So that means you have to take the U divided by T. What is U? 2 units. Let's take 2 here. And T, the distance is 4 units. So here you have to take 4. After cancelling, you are going to get half. So scale factor is half, but we need to check is it positive or negative. Again observe the given triangles. So the U triangle, it's showing upside and the T triangle is showing downside. That means the shape is flipped. So here you have to take the negative half. So the scale factor is negative half. Now we need to find the center. To find the center, we need to draw lines from one point to other. So this is the starting point. Here too you have to draw one line, and again this center to this center, and then this corner to this corner. See, observe here. After drawing the 3 lines, connect at one point, that is our center. So which is 3, 4. So the center is 3, 4. How can you describe the single transformation? So you have to describe enlargement with scale factor negative half about center 3, 4. That's it. Let's go to the next question. Make y the subject of the formula h power 2, that is equal to x power 2 plus 2y power 2. We need to make y as a subject. That means here is our y. So remaining the x power 2 and the multiplication and the power 2, everything you have to remove one by one. Then you will get the subject of y, isn't it? First, what here do we have to remove this x power 2. Already we have h power 2. If we send the x raised to power of 2 to the left hand side, it become minus x raised to power of 2. So what we left? We left 2 y power 2. Here we have a multiplication of 2. So to get rid of that, we need to divide both sides by 2. Then we left only y power 2. We need to get rid of this power 2. How can you get rid of that? Take square root on both sides. Here square and square root gets cancelled. So we left only y. Removing square, so you need to add plus or minus here. Y equal to plus or minus square root of h power 2 minus x raised to power of 2 divided by 2. Let's go to the next one. A, B, C and D lie on the circle. Center O. TA is a tangent to the circle at A. Angle ABC, which is 131 degrees, and angle ADB is 20 degrees. We need to find angle ADC, angle AOC, angle BAT, angle OAB. We need to find all this. Let's find the first one, which is angle ADC. So what is the angle ADC? So this is ADC. So this is angle ADC. What we know? We know angle ABC is 131 degrees. To find angle ADC, we need to recall a theorem, that is opposite angles in a cyclic coordinate, the sum is 180 degrees. So here what are the opposite angles? D and B are opposite angles. According to that theorem, angle ADC plus angle ABC, the sum is 180 degrees. We know that angle ABC is 131 degrees. So let's take that 131 degrees, that is equal to 180 degrees. So from here we can find the angle ADC. So which is 180 minus 131 degrees, which gives 49 degrees. Angle ADC is 49 degrees. Now let's find for the angle AOC. AOC. Now observe here, it is a central angle. Now we need to recall one more theorem, that is So if we have a central angle, so this is the center, the angle subtended by an arc at the center, which is this one. So this center is exactly double of the angle is subtended at any point of the circumference. If we consider this angle as x, then this arc is exactly double the angle subtended at any point on the circumference, which is A, D, C. That means the central angle AOC is twice of angle ADC, isn't it? So what is angle ADC? 49 degrees. Just now we found angle ADC is 49 degrees. So 2 times 49 degrees, which gives 98 degrees. Next, we need to find angle BAT. So we have to find out BAT. We need to find out this angle. We need to recall one theorem, that is alternate segment. What is the theorem? The angle formed between a tangent to a circle and a curve at the point of contact is equal to the angle in the alternate segment. Here, this is the tangent, this is the curve, the opposite segment, and this curve is equal, isn't it? This is the point of contact, which is A. From the tangent, what is the opposite side? This is the opposite side. So that means angle D is equal to angle A. And the given angle D is 20 degrees. According to that theorem, angle BDA is equal to angle BAT. So this angle, the given angle is 20 degrees. So that is equal to angle BAT. According to that theorem, we found this 20 degrees. Now we need to find angle OAB. We need to find this angle. OA, the distance is nothing but radius. If you draw a line from O to B, the distance also radius, and here we formed a triangle, isn't it? Here OA, that is equal to OB, because those two are radius. In a triangle, if two sides are equal, it's nothing but isosceles triangle, isn't it? So here we formed a isosceles triangle, and also we know two sides are equal. So from that we can write that angle OAB equal to angle OBA, because an isosceles triangle. If we form a triangle, and we have to use one property here, that is, in a triangle, sum of the interior angles is 180 degrees. So that means all three angles sum is 180 degrees. So let's take that. First let's take angle OAB. Now let's take angle OBA. Now let's take AOB. Angle AOB. The sum is 180 degrees. Here angle OAB is equal to angle OBA. So here instead of angle OBA, we can write that angle OAB. Here angle OAB and here angle OAB. After adding, we will get 2 times angle OAB. Here angle AO, we need to find angle AOB, that is equal to 180 degrees. We need to find angle AOB. Suppose if you consider this as x angle, you need to recall again the same theorem which we are using for to find angle AOC, that is the angle subtended by an arc at the center is twice of the angle subtended at the circumference. This angle is twice of this angle. That means angle AOB is twice of angle A. Then we are going here DB, angle ADB. So what is the angle at D, which is 20 degrees? So 2 times 20, which gives 40 degrees. So angle AOB is 40 degrees. So instead of angle AOB, we are going to write 40 degrees. So angle OAB, that is equal to 180 minus 40 degrees, which gives 140 degrees. After dividing by 2 on both sides, we are going to get angle OAB is equal to 70 degrees. So this one is 70 degrees. That's it. Let's go to the next question. Simplify 5 times x raised to the power of 4 whole power 3. Now observe here, it is in the form of a, b whole raised to the power of m. Here a is nothing but 5, b is nothing but x raised to the power of 4, and m is nothing but 3. What is the formula? ab whole raised to the power of m, a raised to the power of m times b raised to the power of m. So here also we can write this as a is nothing but 5 raised to the power of m is 3 times b is x raised to the power of 4 whole raised to the power of 3. 5 raised to the power of 3 is nothing but you need to multiply 5 3 times. 5 5s are 25. 25 times 5 is 125. So we need to write this 125 times x raised to the power of 4 whole raised to the power of 3. Here we need to recall one more identity, which is a raised to the power of m whole raised to the power of n. We can write this as a raised to the power of mn. So here we can write as x raised to the power of 4 times 3. 4 times 3 is 12. So x raised to the power of 12. So here we are going to get x raised to the power of 12. So 125 times x raised to the power of 12. That's it. So let's go to the b1. Here also it is in the form of a, b whole raised to the power of m. What is the formula? A raised to the power of m times b raised to the power of m. Here a is nothing but 256. M is nothing but whole raised to the power of 3 over 8. Then times b. B is nothing but x raised to the power of 256 whole raised to the power of 3 over 8. Now observe here 256 is nothing but 4. You multiply 4 times. 4 times 4, 16. 16 times 4, 64. 64 times 4, 256. So 256 we can write it as 4 raised to the power of 4. So let's write it here 4 raised to the power of 4 times 3 over 8. Here we can cancel. We are going to left 4 raised to the power of 3 over 2. Now observe this, the base 4. Base 4 we can write it as 2 raised to the power of 2. Now here these 2 and these 2 gets cancelled. So we left only 2 raised to the power of 3. 2 raised to the power of 3 means you have to multiply 2 3 times. So 2 2s are 4, 4 2s are 8. So 2 raised to the power of 3 is nothing but 8. We simplified this part. Still we need to simplify this. X raised to the power of 256 times 3 over whole raised to the power of 3 over 8. What we know? We know 256 we can write as a 4 raised to the power of 4. So let's write here 4 raised to the power of 4 whole raised to the power of 3 over 8. It is in the form of a raised to the power of m whole raised to the power of n. The formula is a raised to the power of mn. So this part we are going to simplify. Here a is x, m is 4 raised to the power of 4 times n is 3 over 8. This 4 raised to the power of 4 we can write 4 multiply 4 times. 4 1s are 4 2s are 8. 2 1s are 2 2s are 4. So x raised to the power of, in the power what we left 4 times 4 times 2 times 3. So x raised to the power of 4 4s are 16. 16 2s are 32. 32 3s are 96. So the second part is going to be x raised to the power of 96. So 8 times x raised to the power of 96. Let's go to the next one. P is directly proportional to q plus 2 whole raised to the power of 2. P is directly proportional to q plus 2 whole raised to the power of 2. So if you want to write in equal form, that means you have to multiply something to our q plus 2 whole raised to the power of 2. So when q equal to 1 and p equal to 1, so p is directly proportional to q plus 2 whole raised to the power of 2. We need to find p. To find p, first we need to find k. So for that you need to apply q and p values here. So first let's find the k. So what is the p1? That is equal to k times, what is q? Q also 1. 1 plus 2, which is 3. 3 power 2 is nothing but 9. We need to find k. So that's why get rid of this 9. We need to divide both sides by 9. K value is 1 over 9. So let's substitute here to find the p value. So p equal to 1 over 9 times q. They said when you need to find p when q equal to 10. So let's substitute q as 10 plus 2 whole raised to the power of 2. 10 plus 2, which is 12. 12 power 2. So that means 12 you have to write 2 times. 12 times 12. 3 3s are 9. 3 4s are 12. Again 3 4s are 12. So finally what we got, 4 times 4 is nothing but 16. So the p value is 16. And that brings us to the end question 22. We only have one set of questions left to go. In the next and final video of this series, we will be solving question 23 to 27. If this video helped you, please give it a thumbs up. See you in the next one.